In problem 4, we're asked to graph y equals negative 5/3 x minus 1. This is a linear equation in two variables, and it's written in slope-intercept form. So our easiest approach to be graphing will be to plot the y-intercept, and then use the slope to find additional points on this line, which we can then connect with a straight line. So to start, this minus 1, we have y equals negative 5/3 x minus 1. This minus 1 tells us that our y-intercept will be the point, or occur at the point, 0, negative 1. And as we see, if we plugged in 0 for x, we would indeed get negative 1. We can identify that just as the constant term, though, when this is written in slope-intercept form. Again, general slope-intercept form, let's jot that down. General slope-intercept form is y equals mx plus b. And so I'm looking at what's that b, and here it's negative 1. That tells me that the y-intercept is 0, negative 1. Next, moving on to the slope, this coefficient on x is going to give me the slope. So the coefficient on x is negative 5/3, so my slope, and I generally use m to denote that, will be negative 5/3. Again, remembering that this is rise over run, so I'll use that ratio to see how I can move from one point to another on the graph of this line. With these two pieces of information, we're now ready to sketch this graph. So we'll plot the point 0, negative 1. And so I have that plotted. And then in order to use that slope, I have negative 5/3, which I can write as negative 5/3. And thinking of that as rise over run, that means that I will go down 5 units. So I'm going to jot down 5 units. And then right 3 units. So moving over 3 units. And I see here that I'm at the point 3, negative 6. And so the point 3, negative 6 will also be on this line. If I want to find more points on this graph, particularly in the second quadrant over here, I could also think of that negative 5/3. So I wrote it as negative 5/3. I can also think of rise over run as 5 over negative 3, giving me the same number, negative 5/3. That's helpful in that, from that point 0, negative 1, I could also have gone up 5 units and left 3 units. So I'll do that here. And that'll put me at the point negative 3, 4. So I'll plot that. And now I have plenty of points, and I can connect these with a straight line. So I'll come in, and I'll draw a straight line through them. And then lastly, to show that it continues indefinitely, I'll put arrows on each of those ends. In terms of reviewing this topic, the key topics that we're looking at here the overall topic is linear equations in two variables. And second to that, or more specifically, what we looked at here was the slope-intercept form. So coming over to our ORCA text, which again can be found at spot.pcc.edu/math/ORCCA/ORCCA.html. What we're looking for here, if we come to Chapter 4, we have graphing lines. And looking in there, there's a lot about that 2D coordinate system. Section 4.5 in particular covers slope-intercept form. There's a subsection here that is specifically what we were looking at there, though. So if we come down and we look at subsection 4.5.2, there are some examples, there's an embedded video, and more practice problems there. So let's jot those down real quick. Where we'd find those: ORCA, section 4.5, and specifically that subsection 4.5.2.